In this video, we're going to look at a very common mistake that some students do when they are first learning U-substitution, and we're going to look at why it is a mistake. So I'm going to set up an example. Suppose we are trying to find the antiderivative of the cosine of x squared dx. Many students, when they are looking at a problem like this, correctly identify that we have a composition. And so they immediately think that what we should write is that u should be the inside function, which in this case is x squared. And they will then write correctly that du is going to be 2x dx. Now, what I want to realize is that there is no x inside my integral. This x is missing, and so this next step is an incorrect step, but I want to show you why this goes wrong. So students will take this, and as a bad, incorrect U-substitution, they will write the following. They will take this stuff and they will say, well, gee, I'm going to rewrite this integral, so I'm going to put a 2x over a 2x, because 2x over 2x is 1, times the integral of cosine of x squared dx. And let's see, this 2x matches up with that dx, and there's my du. So my work now becomes 1 over 2x times the integral of the cosine of u du, and that's going to go back to 1 over 2x times the sine of u plus a constant. And so my answer is 1 over 2x times the sine of, let's see, u here was x squared, so I've got the sine of x squared plus a constant. I'll clean this up and write my answer as the sine of x squared divided by 2x plus a constant. But I want to remind you, this answer is wrong. And we can show that it's wrong by differentiating the answer and seeing what we get. So let's look at this. Actually, let me change it to a different color here. Look at this. If I try and take the derivative of our answer, which is sine of x squared over 2x, I have to use the quotient rule on this. And when I use the quotient rule, I'm going to get the derivative of the top times the bottom minus the derivative of the bottom, which is just a 2, times the top, all over the bottom squared. And now what I've got to do is I've got to deal with this derivative. And what I want to notice is that this derivative here requires the chain rule. And so when I do the chain rule on that particular derivative, I'm going to wind up having, let's see, it'll be cosine of the junk times the derivative of the junk, which is just a 2x, times that 2x, minus this stuff, all over, well, when I square 2x, I'm going to get 4x squared. And now I simply need to clean this particular derivative up. This is going to be 4x squared times the cosine of x squared, and let's see, don't like where that popped up, minus 2 times the sine of x squared, all over 4x squared. And I can do one more piece of algebraic simplification. This will simplify to cosine of x squared minus the sine of x squared over 2x squared. And that is most certainly not equal to cosine of x squared, which was the integrand in our original problem. If you go back and look, we were trying to integrate cosine of x squared. And because this derivative here does not work out to be cosine of x squared, what we know is that the antiderivative of cosine of x squared dx, whatever it is not the sine of x squared divided by 2x. And so this particular work up here is wrong. And I'm going to cross it out saying this is not what you want to do. And the problem is variables cannot go through the integral sign.